can, if you don't know what you measure, that's not a good thing. So the basic is, the big thing is to know the basic of machines and also measurement fixtures and something else. Measurement device and measurement specifications for use for that. And what is a unit? Units. We will have it here. I think basically in US you measure with yard, or foot or something. So, but in our case we are metric system. We measure in meters, in second degrees. But you can have also units with like the electrical results with ampere, volt, ohm, and temperature is also a thing you can measure, like Celsius, or how is it in English? What you have in US? Sorry? Fahrenheit, sorry. Thank you. Yeah, that's also a unit to measure. But in our case, machine measurings, we measure DMG machines in metric. So not all, sometimes customer has also the inch system, and I think then you have also to measure it in inch. But the basic machines here from the Germany plants are measured in the metric system. So, and you can imagine our machines are for measurement. You have a tolerance, and the tolerance for our unit or measurement result are here in 20 microns mostly for the basic machines or for the standard machines. So we have more, we call it sometimes half tolerance or precision. Then the tolerance is more or less than, I think the biggest value are 15 microns or something else. So that's, in that case, is mostly to reach it with compensations. So that's our machine parts will be delivered in a big range of tolerance, or not so big range of tolerance. So the parts are very, very good work pieces. So, but anyway, you have influence with rail guides and also bearings. What else? So scales that can have an influence of our machine tolerance. And in that case, but that's later on, we have some compensation tables or sec tables, temperature tables for everyone, for everything to adjust. So, and what is the size? Yeah, you know it on your pants or sometimes your sweets. You have also to choose the right size, and also you have to choose the right size of our units. For example, meters, seconds, micrometers. So specifications, collection of rules, compliance, and we archive it in a correct result. So basic measurement regulations, use correct measuring equipment correctly. So that's something we have, and I show you in the short movies, and also with the lever gauge measurement angle that you have to know it, that can have, for example, an influence. Cleanless, yeah, also a big thing that we measure on surfaces like tables or pallets or mandrels and any stuff you frames. So you have to be sure for every measurement that it's been clean. So please take grinding stones, or you have first to be wash it up or clean it up with some spiritus or whiskey. No, yeah. So cleanliness is also a very important thing that we have to be care of. Then a big thing we talk, the temperature. So I think everybody knows the temperature that we have to use for DMG products. Or another thing, did you know, or do you know what you think is our temperature where we measured here in Pfronten our machines? Is there any idea? So here in Pfronten plant, I think every German plant, we use 21 degrees. So that's I think the most rooms are now here at the plant are climate rooms. So we have always the same temperature, and this is also, we call it a basic temperature value, that you have the things that all machines have in the protocol. It will be measured by 21 degrees. One big thing to know. So that was then also one thing that I told you before, that is the counter measurement. So to control your measurement, or to rule out that you have an error here in picture or something, that's the counter measurement, or the meaning of the counter measurement. So everything that you measure, it doesn't matter what, if you measure meter, temperature or something, you have to document it and you have to result it clearly. So I will say that's a big thing. I know from my experience, you have to look for the way, in which way, or I say the signs. So is my result is negative or positive? So then please note it or document it with, for example, plus 15 microns. So if you do it without sign, it can happen that you do a counter measurement and you forgot in which way was my result was minus or plus. So then document it with a minus or a plus. So that's a tip from me. I don't know if you do it before, but I think so. So regulation, special measurement regulations. We have in all machines our acceptance report, so or protocol, and that was there is the machine accuracy and the values are right down in that protocol. So also I will show you later on some protocols of that machine, and And also we have an installation or a commissioning protocol that will, if you have to do it in the past, I think you have also give to the customer an installation or commissioning protocol of your measurement. And also sometimes we have assembly protocols. So protocols are specified by the manufacturer. So that's sometimes we have difference, but anyway, I think that's a logical thing. We have, for example, 5-axis machine. So we have protocol for all axes first. And later on, there comes some round axis to measure, or at the end, if we have all measurements done, it comes to the kinematic in 5-axis case for uses. So, which measuring equipment is used? Usually, we talked about, we have dial gauges, we have the fine pointer dial gauge with 0.1 treble and up to 1 micron millimeter display. Then we have the feeler lever, or the lever gauge, or how do you call it? Indicator. I think indicator is a common name for that. But for that one, be careful that you always do it parallel to the measurement surface. So then we have the test manual. So maybe I can show one. We have one on site. So if I show you that example, in that case, normally 300 millimeters long and around 40 millimeters in the diameter. 350 is it. So in that case, we have an HSK, and maybe, did you see it in the camera, or should I make the camera bigger? I can see. You can see. Yeah, also in HSK we have 4 positions, and we will go later on the test manual how to use it. Yeah, I think SK and also the SK Big Plus. There is the different, the SK, there is only clampus and cone, and the SK Big Plus, they will be clampus, cone, and surface on the mandrel. So then also BT, CAT, and NC, I think, but this is very rare. Especially some tool manufacturers, we have to use the Tapto tool clamping system. Is there anybody who don't know the Tapto? Okay, which measurement equipment is usually used? Y-Dosher. T-angle T-bracket. So T-angle T-bracket, that was the one what I show you here in the front. No. We have a magnetic base, and we have a stop there was inside the T-slots. Then we have a frame angle. Frame angle, yeah. Also, we will show you in the couple days that we have. And then we have frame angles. You can have it with a grinded rock or with a grinded steel. That's sometimes different. And also, if you don't have a frame angle or something else, you can use a parallel bar, mostly steel and also rock or steel. So, and then we have leveling devices. That's mostly spirit levels or leveltronics. So that part, I think I have here one. So we use spirit levels with a water ball inside or a bubble in the water, I think. Actually, I didn't know the name in the common name here, what you use in US for that tool.
A level?
Only level, yeah, okay.
We call it like, yeah, machinist level or something.
Yeah, that's one that we use. That's normally the first tool if you have an installation of a machine that you bring it into the right level or nearly to the exactly level for installation. Okay, so die gauges, I only want to talk a little bit about the die gauges because there are some interesting. So draft measurements, point measurements also possible with a dial gauge, and you can also be a draft measurement. But there you have to be careful. There must be sometimes two bearings here in this shaft, so that then the dial gauge can do this draft measurements. For point measurements, it's always be the same. But if you have a draft, then it can have an influence of a bad result. And there, the indicator or feeler level measurement device, wie soll ich das auf Deutsch? Ja, dann denkt. Yeah, we have. I show you one thing. Maybe I switch back to the camera. No. Some indicators, they have a ruby on the point. Did you know why we have the ruby or the sapphire ball? Not sure, because the ruby will be used. We have sometimes here on our machines scales or something that they are magnetic or they have a magnetic field. So, and therefore we use this red sapphire ball, or we call it also a common ruby, that there is no contact to the directly magnet sometimes. So that's the reason why we have on the indicators sometimes a sapphire ball in the front. So you see it here. So that's the thing we talked about with the angles. So dial gauges, all dial gauges have a reversal or a changeover error. So mostly are very correct, but mostly you can be 2-4 microns, I don't know. So, and also, if you imagine you have to measure all axes, 5 axes or something, and you forget to do the countermeasure or so, or reversal measurement, then you have 4 microns reversal failure in, and then you have a bad result, or a big measuring error. So therefore you have always to be sure that the reversal or the changeover or gap, how doesn't matter how you call it, that you bring that failure out. So also we think if we do the practice part of that training, you see how you can avoid the changeover on the dial gauge. So here, that's an example. I will show you that dial gauge. If you look at the camera, here there is a dial gauge. They have a big wave, and that's the same like I show you now in the script. They will be with a shaft, with a toothed shaft, and we have a big tool. We have two toothed wheels in at the shaft, and then we have an pointer here, and at the other side we have a spring inside, one spring, and also a round spring. So that's normally the construction of that dial gauge. I have you principle. We measure with that dial gauge 10 microns. There is another. So that's that dial gauge I show you in the camera. The other thing is, if you have an dial gauge like that one, so that we call micrometers. Micrometers, you can measure 1 microns, and that's different construction or design. The design at that way, the pointer in that one will be lift out with a twistle metal strip. So there's a bell crank lever. If we go in, the bell crank lever go to the right side and twist or tight these metal stripes, and the indicator will go to the right side. So they are very sensitive measurements, because the construction of that way is a twisted metal stripe inside. So in that case, we have a slit washer inside. So that will be, this is more or less the bearing. Also, if we have a contact point, or you can do a draft with that dial gauge, so that will give you a good result. But also that dial gauges, they have and change over every one of that. But they are very less. I think there are sometimes 2 microns, around 2 microns we have change over at that dial gauges. Okay.
And now you're saying with those dial types, you're supposed to have a second, or like a bearing on the tip. Is that what you're saying? One of the slides? Like,
yeah. So normally, I know it from that case. Normally there will be the better thing, so that's not so sensitive. Also micrometer, and normally what I show you in the camera, that's the manufacturer what called MAR. So there will be a design with two bearings or something. So that, but you can use it also, I think. But they are sensitive, more sensitive. Manufacturers Johansson. It comes from Sweden. Yeah. It's gonna. Okay. So my colleague told me that I showed you an old timer or young timer, so that's not available anymore. But anyway, yeah. So I think the better thing is if you measure it with a die gauge, like maybe that one. Also the indicator or the feeler, lever feeler, I don't know how he called, is also available to do it with the draft, to do a draft measurement. So that's, I think you do it every time if you measure also, but there you have to be careful at the measurement angle that we have. Always you have to know, look that this is parallel to the surface to measure if you use the indicator. But you can do draft also. Point measurement you can do also, but also for point measurement that will be better dial gauge. You can do a point measurement also here, but you here see that's not parallel, that's 90 degrees, and you can, if you remember the movie, then you can have a bad result about sometimes around 10 microns failure. Yeah. But so here we have judge for yourself. If a measurement carry out in the opposite direction to setting, a measurement error will be occur. So that's sometimes the reversal or the backslash or something else that the die gauges has. So therefore you have to be sure, maybe you do a reversal or a counter measurement. So if you see, we have, for that example, we have here an end block that we measure always to the point. So there are some forces that we have to influence. So you have to be sure that you go with the same speed on it. If you do a counter measurement in the vertical position, so then you have to be careful about that you have to always do it with the same speed and have also an influence of your measurement. So, was heißt denn Reibkraft nochmal? Maybe. Yeah, if you draft it, we have an force friction. Yeah. If you draft, then you have a frictional force. So that means in that way we have a friction force. So it has always an influence of the backslash in the, I say, axial gap or something, that that the die gauge has. So, and to that one carry out, you have to be careful about speed. If you have point measurements or speed, you have friction or draft measurement, so that you have the friction force. In that case, you have the spring force, and then you have the backslash. So we call it in that one backslash, we call it U in this example. So and I told you every die gauge has a backslash. Then you have all to figure it out or to see the backslash out. You have to do a reversal or a counter measurement. Very important. Bye bye. Yes. Pointers, offsets. Oh, I'm not sure how is this picture for. I will jump over. So measurement setups. The measurement setup must be enable reliable measurement. It is stability. I remember the movie. You have gravity or something, and also that must be checked and to maybe avoid it too long. If you have a too long setup or pictures, then you have a bigger influence with weight and gravity. And attention, never attach the magnetic stand to the spindle nose, because magnet can go to the spindle nose, and there are some magnetic fields that can look for metal chips or dirt, material dirt. That is to be avoided for spindle nose. Very critical.